Hello and welcome. This is the second video in chapter 1. This is section 2, and it's a short one, but it's an important one. This is about the particle model. Now, one of the underlying assumptions we'll be making about just about all of the examples we do for the next several chapters, at least for the next 11 chapters, we'll be making this tacit assumption. So for all those previous examples that we saw in the first video, the person running, the cars speeding up or slowing down or constant speed, we can simplify the situation if instead of considering the entirety of the car or the entirety of the object, we just paint a single dot and just look at the dot. Okay, because we have to ask ourselves, does the shape of the object affect the actual motion of the object? And of course, the answer is absolutely yes. Obviously, the shape of the car affects how quickly it'll speed up, how quickly it'll slow down, the shape of the tires, the length of the tire treads. You get the impression that we could just go on and on, and with athletes as well. I mean, height, foot size, strength, all these things affect the motion of an object. But those are all higher order complications. And really, an important thing is, does it affect it enough to change the answer significantly? And if it doesn't, you can safely ignore it. So instead of redrawing the picture every single time, we're just going to write a dot. And that dot will represent the location of the object, as we'll see in a minute, because it'll turn out that this will be helpful for us to translate this into mathematical terms. And of course, on the next slide here, we see an example of an object settling or an object launching, and we're going to add a lot more to these slides. But this is really the basic tool we need for these motion diagrams. It's going to be these particles. And as we'll see in the next section, these dots will represent actual positions. Thanks for watching as usual. We'll see you on the next video.